everyone, this is KP the Math G for the fourth time. This is my fourth video. I used to do videos, I want to say back in 2018 or 2019, and I did several there, but that was then and this is now. I'm starting a new set of videos, and I've been dealing primarily with the calculus. And in calculus we use limit quite a bit. We've been talking about limit for some time, and continuity, but we're going to use limit today to find horizontal and vertical asymptotes. Again, coming from KP the Math G. Alright, we want to find, I call this HA, okay? This is the horizontal asymptote. If you see me with, say, the H dot A there, that is going to be horizontal. Vertical will be VA, and that's the way I abbreviate it. So, first of all, what is a horizontal asymptote in the first place? It may be good to know that. Let's say that you have a graph here. Matter of fact, y is equal to 1 over x. Most likely you will have something that looks like this, and the horizontal asymptote, horizontal horizon, it goes straight across here. Okay, this is at y equals 0, which is the same thing as the x-axis. We say y equals for the horizontal asymptote, x equals for the vertical asymptote. Alright, and so an asymptote is just a boundary line. We don't see it on a graph, but the graph will reveal it. And as it comes down, it gets close. It never really crosses that boundary line, that little dotted line that you're not seeing really. And I know that's not a really great graph, but that's the idea. So y is equal to 0 is the horizontal asymptote. We could do another one here, let's say at 2. Okay, alright, so something would look like this maybe. I mean, actually it could even do something like this. It could hug close this way and then go down this way, but you see this is going toward, negative infinity. This way to the right is always going to be going toward positive infinity. So when we look at limit, especially horizontal limits, you will always see negative or positive infinity. Keep that in mind as we get into the lesson this evening. Okay, so let me show you what I'm talking about. Let's look at this horizontal asymptote here, and there is a rule that you probably learned back in pre-calculus about the degree of the numerator being less than the degree of the denominator, and what is that horizontal asymptote. And we're going to find out that the answer is 0. Okay, well, let's look at this. The limit as x approaches, and let's just do positive infinity. It doesn't matter. Alright, we're going to take this function of y, okay, x over 4x squared minus 7. One of the ways to find the asymptote, the vertical asymptote, is to consider the highest exponent right here, which is 2. And we're going to simply divide each term in both numerator and denominator by x squared. In this particular case, it's x squared. Had it been x cubed, we would have divided by x cubed, and so on. Well, here's our limit. Limit as x approaches infinity. Alright, so here we go. We're going to say x over x squared divided by 4 x squared over x squared minus 7 over x squared. Alright, well, let's kind of reduce that a little bit and see what happens. Okay, the limit as x approaches infinity. Let's do this, and we could have done negative infinity just as well. X squared over x, x over x squared rather, is 1 over x. Okay, and then 4x squared over x squared, provided that x is not equal to 0. That's what we've got to look at each time. This divides out, and we just have simply 4 here, and then this is 7 over x squared. Consider for a moment, though, that as x goes to one of the infinities, negative or positive, either one, that the greater this denominator gets, there is a number that this approaches, and it's always going to be 0. Certainly 1/2 is larger than 1/5, which is, 1/5 is larger than 1/20. This, as we get further and further out, we get closer and closer to 0. And I don't have a calculator handy at the time, but my goodness, if you went out to, let's just say 2, 3, 4, 5, 6, 7, 8, so on like this. Alright, well, that is going to be much closer to 0 than 1/2 is. 1/2 is 0.5. This is, well, very, 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 very small. So eventually, as you go further and further out, you get closer and closer to a number called 0. So that limit is 0. So anytime you see that limit 0. So in other words, let me get a different color. This limit here, looking at all 3 limits, okay, right here, this limit 0, because x is in the denominator. This limit is going to, well, it's going to increase even faster. Okay, the denominator is going to get bigger much, much quicker because it's squared. And so this is definitely going to 0. So here's what's happening here. The limit as x approaches infinity. Alright, so actually what we're looking at is each one individually, 1 over x, divided by the limit as x approaches infinity 4 minus the limit as x approaches infinity 7 over x squared. Okay. This answer here is 0. This answer here, no matter how far out we go, the answer is still 4. And this answer here is 0. So 0 over 4 minus 0 is 0 over 4, which is 0. So, therefore, go back to my black ink again. Y, here's our answer here. Ooh, okay. Let's put it right in here. Okay, y equals 0 is the horizontal asymptote. Okay. Alright. And so that is the way that you find the asymptotes for this. Alright, y is equal to 0 is the horizontal asymptote. So, what that means is, well, let me find my eraser again. I'm going to erase all of this again. So bear with me while I erase. I've already shown you before, but I'm going to show it yet one more time. Y equals 0, guys, is the x-axis. So the thing about it is, alright, so we know that we have an asymptote. Now, whether we know that it's going to be down here or starting up here, we have not determined that yet, but we do know that going in positive, if we go in this direction, positive infinity is in this direction. Negative infinity is in this direction. What we have here is, well, we don't know. Right now, we're saying that this is going to be right here, this dotted line here. And the graph is probably going to do something like this. Now, where it is out here, there is a vertical asymptote as well. So wherever the vertical asymptote is, that's what we need to go by. I could tell you what it is. It's actually 7 over the square. Actually, the square root of 7 over. So I'm sorry. The square root of 7 over 2. Okay, so wherever that is, somewhere positive over here, and this asymptote, it's going to either go this way or it's going to be down here. Okay, it's either going to do this or it's going to do that. Come up and do this right here. Okay, so that's what we're talking about when we talk about infinity. It's going to the y. All we're looking for is the asymptote. So y is equal to 0 is the horizontal asymptote. Okay, and I could tell you how to get this later on, but right now we're looking at just the horizontal asymptote. One little secret though, like I pointed out earlier, if the degree of the numerator is less than the degree of the denominator, 1 is certainly less than 2, then you're always going to have a horizontal asymptote at y equals 0, which is just the x-axis. Okay, you can graph that, you can see what it looks like, and so on and so forth. Okay, and then that's what we're talking about here. All right, so that's that first example. And probably I could do more to this problem, but for right now, we're just trying to find the asymptote. Okay, so in this case here, we'll call this case 1. Alright, case 1. Case 1, we see that y equals 0 is the horizontal asymptote. Okay, at least we got that far with it. Okay, and we could do more with that. Okay, so let's do another one. Let's pick y is equal to, this is case 2. Case number 2. Alright, and here we go again. I mean, this is the degree of the numerator is less than the degree of the denominator. In this case, the degree of the numerator is going to equal the degree of the denominator. So in this case, we're going to pick up on y is equal to 6x squared plus 3 over 3x squared minus 7. Okay. Now remember, the highest exponent, well, there is nothing higher than 2. Both of them are 2, aren't they? Okay. So this one had a 1 here, this one has a 2 here. We divided each term by x squared. So in this same thing, we're going to do the limit. Again, as x approaches, and you could say positive or negative infinity if you want. This is approaching, okay? And you can say, okay, here we go. 6x squared over x squared minus 3 plus 3 rather over x squared over 3x squared over x squared, okay, and then minus 7 over x squared. Now, instead of doing each one individually where you have 4 separate limits, which is, if your teacher tells you to do that, then do it, okay? They may tell you to just look at this and come up with the answer. See, these x squares divide out. I hate to use cancel out. A lot of people do that. So what we really have right here, just go up here. Let's say what we got here. We got the limit as x approaches either plus or negative infinity, either one. Okay. Let's see what we got. 6 plus. Matter of fact, this limit right here is 0, isn't it? And we're doing this visually now. Alright, this is 3. 3 minus, as we saw from the last example, this is also 0. So what we have here is the limit as x approaches positive or negative infinity, either one. We have actually 6 over 3, which is 2. Well, that is 2. So y equals 2 is the horizontal asymptote. And again, let's see. Let's put it up here. I guess, well, we can flip this board over. Y equals 2. Alright, so we can just flip this board around. Ooh. Okay, and the problem was y is equal to 6x squared plus 3 over 3x squared minus 7. We found that if we did the limit, that the horizontal asymptote is at y equals 2. And all that means is, I may not know exactly what the graph is going to look like, but I do know that at 2 I have a horizontal asymptote. And I don't know, let's see, again, I could tell you how to find the vertical asymptote. There is going to be one, okay, but needless to say, wherever it is, it's going to be over here somewhere. Square root of 7 over the square root of 3, which is the square root of 7 over 3. And whatever that is, okay? We're not going to get into all that just yet, okay? But anyway, you see this here, the graph is going to do something like this, or it's going to do either this, or even this, okay? Alright, and that's kind of how that goes. We just know that the horizontal asymptote is at y is equal to 2, based on what we just did. Okay. Well, and it could do something else. And by the way, I drew that kind of, that's really, it could do this, by the way. It could do that too. And I say that because x squared is positive. Okay, even if this is minus 7, x squared is positive. It's possible that it could do something like that. Okay. So anyway, that's how you determine, though. We do know that the horizontal asymptote is y equals 2. So let's go back to the other side again. Okay. And let's erase all this other and let's determine something here. Okay. Okay, so we did this limit, doing that. Okay. Alright, so let's take a look here. We do know that y equals 2 is the horizontal asymptote. And here again, you can actually, if these exponents are the same, the lead coefficients will tell it like this. Okay. Even if it's written like this, maybe you might have something like 6x squared plus 3 over negative 7 plus 3x squared. Still, you're looking at just these is what you're looking at because the degrees are the same. We're not worried about this. That's 0 there for the limit. So really we have 6x squared over 3x squared, 6 over 3, which is 2. So that's what you can look at, okay, that way. So just look at the lead coefficients. All right, so like that. Okay. Now, we do not have a horizontal asymptote if the degree is larger. And I don't want to get into the slant. It's called a slant. Well, it could not be a slant asymptote. The slant asymptote would come into play if the degree is 1 greater, only 1 greater. Let's say we got x squared minus 1 over x plus 2. In this case, we do not have a horizontal asymptote, but we do have a slant asymptote. And there's a way to show this. And I'm not going to take the time to do that at this point. Maybe at another time, but this would be a case 3. If it's 2 greater, well, we got a different situation. And it may be an asymptote, but it may be like a curved asymptote or something. So it gets kind of weird as these numbers get bigger and bigger like this. So anyway, and of course you can draw these on your graph. Like I say, I don't have my calculator. I do have one, but it's not handy, and I don't have it. Well, for the lack of time, I don't want to get it out for right now. Just be suffice to understand that you do have an asymptote at y equals 2. If this had been like 9 over 3, this would have been, okay, so 9 over 3, this would have been y is equal to 3. If this had been, well, let's do it the other way around. If this had been 3 over 9, this would be 1/3, okay, so like that. It's easy to look at that way, okay. 3 over 9 is 1/3. So, I mean, that's what we're doing here. And there we go. Y is equal to, always y equals. Okay, so that is the horizontal asymptote. You really have 2 real cases. And somebody will say, well, you got the third one. Well, yeah, I know, but that's not a horizontal asymptote. These 2 will get it this way. Okay, and once again, even if you had y is equal to 3 over x squared minus 4, you can still do this. Okay, so you do your limit as x approaches infinity. Okay, so let's see. Use a square here again. So we can make this to the 4th. We don't care. 3 over x to the 4th. Now, let's make this x squared for that matter. Okay, so now x to the 4th over x to the 4th minus 4x squared over x to the 4th. And you can very easily see this is going to be 1, and then this is going to be 0, and this is going to be 0, and 0 over 1 is 0. So again, y is equal to 0. And again, that's if the if the degree, this degree is actually 0, x to the 0 is 1, and 3 times 1 is 3. So this degree is smaller than this one here. Alright, so just understand that situation there. Okay, so we looked at these two scenarios concerning the horizontal asymptote. Alright, so now what I want to do is I want to find the vertical asymptote, and then maybe even find both the horizontal and the vertical together on this next problem. And this may be the last problem that we do. Let's go ahead and erase this. This is for finding the horizontal asymptote. Okay, I probably could have flipped the board, I guess, maybe. I kind of like that I can do that. Okay, so let's do vertical. What is a vertical asymptote? Okay, vertical asymptote is going to be x equals some number, and let's say that if the vertical asymptote is x equals 2, then at 2 you have a vertical asymptote, and this thing is either going to go down, up like that, or something like that maybe. Okay, but it's going to be that boundary that you really don't cross. Okay, so anyway, all right, that's the vertical asymptote. So let's take a look at the vertical. Let's get an example here, and we are going to do the vertical first. And here's what we got to do. Let's say we got y is equal to 3 over x plus 2. Okay, now the limit is, we're not going to see a limit of infinity here, although we do have infinity when we graph on the graph, but we're not going to have a limit that says a limit as x approaches infinity like we did with the horizontal. The vertical is just, we're going to look at this denominator right here. Okay, and we're going to set this denominator equal to 0, and of course easily done, x is equal to -2. That's what your limit's going to be. So the limit as x approaches -2, and we are going to do both left and right limits. Okay, so this is going to be 3 over x plus 2. Obviously, if we plugged in -2, -2 plus 2 is 0, which means that would be undefined, but we are looking at it as it approaches -2 from the left. So let's get on our number line here. Let's put a little number line. Here's -1, here's -2. Tell you what, let's pick -3. We could pick -2.00001, whatever we wanted to, but we want to just pick negative. Let's pick a negative number here. Let's see what that's going to be for us. If we plug in, say, -3, okay, I like to pick something pretty close as x approaches -2 from the left, 3. Now, we could have picked a different number, but if we pick -3 plus 2, we're going to see that the numerator is obviously positive. We don't care what the number is. This could be 30 for all we care. It's still a positive number. Okay, what we're determining is this going to be a positive infinity, or is it going to be negative infinity? That's what we're finding every time. Is the answer going to be a positive infinity, or is it going to be negative infinity? So if we have this here, then this numerator is positive, while the denominator is -1, and -1 is negative, obviously, and a positive over a negative is a negative, which means that we are approaching negative infinity. Okay, at x equals -2. So that's negative infinity. Okay, like that. That's the way I would do this if I were you. just pick something to the left of -2. That's negative infinity is going in this. Here's where our asymptote is. Negative infinity is going in this direction, so we want to pick something in that direction. When we want something in positive infinity, we can pick something and don't have to be a positive number. It can just be the number to the right. So this time we're going to pick -1. So let's see. The limit as x approaches -2 from the right this time, and we still have +3 over this time -1 plus 2. I know this teachers will probably say, KP the math G, what are you showing my kids? Well, I'm just showing you how to get infinity here. That's basically all I'm showing. The 3 is positive. This could be 300. This could be 3,000. But needless to say, it is a positive number. This is also positive. -1 plus 2 is 1. And 1 is also positive. So positive over positive is a positive infinity. So the graph, what does that look like? Okay, I don't know I know what the horizontal asymptote is too, don't you? Because the degree of the numerator is less than the degree